Okay, some more problems from section 9.1, and this is number 58. And they wanted you to find the, again, a power series, including the formula for the nth term, and 1 over 4x, and they kind of gave you a hint on how to do this, but you could probably figure out yourself anyway. We'd write 1 over 4x as 1 over 4, 1 over x, and we want to get this into kind of a geometric form, so we could add 1 and subtract 1 to the bottom. That's just adding 0. So that won't change anything, and then you could just factor out the negative. You could have 1, and then you could take a plus, and then you could have x minus 1, and then you could change that to a double negative, so we get 1 minus that, so this would be my r. And then we could actually put the 4 up here if we wanted to, write it up on the top, and then you could see once you kind of adjust it like this, you could see that if you've got your negative, then this is going to be your r, so your r will be negative x minus 1, and your a would be 1/4, and you could write the series like this. Or you could multiply a regular series by 1/4. It's going to work out the same if you just put that in last. So this is my first term, 1/4, and then minus a times r, so that'd be negative, and then another a times r squared, etc. So this is how we would get the series. And it would be negative 1 because we've got alternating signs, so it'd be negative 1 to the n. There's my 1/4. All right, this is my common factor. That's my a sub 1. And then x minus 1 to the n. Okay. And we could always write down our n, so we can see this is going to n equals 0, because it's going to go from 0 to infinity. 0, 1, 2, 3, and n, and hopefully you would see how those all work out. So that would be the summation from n equals 0 to infinity of 1/4, negative 1 to the n, x minus 1 to the nth power. Now this converges for the absolute value of r, and this is r, less than 1. Well, the negative sign will just absolute value out. I'm sorry about this. Be straight, okay? So that's just x minus 1, absolute value of that. So that means x minus 1 is between negative 1 and 1. If the absolute value of x minus 1 is less than 1, we have this. And then if I add 1 to both sides, this is 0 and 2. So that's my interval convergence, 0 to 2. Okay? And 59, it's a little bit better solution over here, so let's take a look at this. I kind of got carried away on the algebra on the other one, so this is 59. And it was 2 minus x, and they gave a hint. They told you to rewrite this. Well, 2 minus x, I can make this as 1 minus x plus 1. What's 1 plus 1? 2. So this is the same thing as 2 minus x. And then what I can do is I can factor out the minus sign. I have 1 minus x minus 1. And there we go, we compare that with our geometric series. And a is 1, and r is x minus 1 because it's 1 minus r. So there's my series, 1, x minus 1 is my ratio, x minus 1 squared, x minus 1 cubed, etc., x minus 1 to the n. So there's your nth term. So the summation will be n equals 0 to infinity of x minus 1 to the n. When n is 0, I've got 1, and then this generates this, okay. It's always nice to write that out so you can make sure that it generates the series you want. The interval convergence is the absolute value of r is less than 1, so absolute value of x minus 1 is less than 1, so x minus 1 is between negative 1 and 1. Add 1 to both sides, and we have 0 to 2. Okay, so my interval of convergence, my IOC is 0, 2. Interval of convergence. An alternate solution, this is another way to do this, just in case you might be interested. You can rewrite this as 1/2, 1 over 1 minus x over 2. If you multiply this out, you do get 2, and you get minus x. So it does work out. In this case, the a would be 1/2, and the r would be x over 2. So you'd have 1/2, and then just keep multiplying by x over 2, 1/8 x squared, and then we would work it out like this. So this would be 1 over 2 to the n, x to the n. So it's a little different way of writing it, but it still works. It's another valid series for that. And that would be your general term. I wrote my n's here. Okay, that was 59. Also, we had to do 63. And 63, a series for the natural log of x, starting with the power series for 1 over x in exploration 1, part 4. Find the power series for the natural log of x centered at x equals 1. So this is what we had, 1 over x. This was the series we had in Exploration 1, Part 4, so you go back and look at that. 1 over x. So we came up with this one. I went back and looked at it. 1 over x was a 1, and then, you could actually see the ratio was negative 1 minus x. That was the r. So this was the series 1 minus x minus 1 plus x minus 1 squared minus, so again the ratio was negative x minus 1. And again you can see that if you look at page 477. It's pretty obvious now, I hope. And we know that if the natural log of x is the antiderivative of 1 over t, right? The derivative of 1 over t is the natural log. So we'll just take the antiderivative of this. So the antiderivative of this will also be the series from the natural log of x. So I'll take the antiderivative of both sides, so to speak. If I take the antiderivative of this, I get this. And then if I take the antiderivative of this, and what I did was I looked at my nth term to kind of figure it out, because I was kind of running out of room anyway, so I didn't want to do term-by-term integration. I could have, but I would have a little trouble doing this without a u substitution. But if you use the formula, it's not too bad, because this is a constant, so that just stays. It's not. There's not an x in there, so we can leave it like that. So that's negative 1 to the n, and then this is going to be. We're using the t, and we're going to integrate that. But if I take the antiderivative of this, that will be x minus 1, and if I add 1, that'll be n plus 1 divided by n plus 1. So this is how you can generate the antiderivative just from using the general form, rather than doing term by term. And then I kind of wrote it out term by term. So the natural log of x equals, and this is where this 1 comes into the x minus 1. And if we would have used this u substitution, that would have worked. But if we just look at this, it's going to give us the same thing. When n is 0, we have 1, and then this is 1, and that's 1, so it's x minus 1. When n is 1, this is going to be a negative. So by integrating the general term, you get a nice formula for your series, and you can write it out like that also. Then you can write out the terms rather than integrating and then write out the general form. Okay, so it would work out the same way. And again, this would be positive. You know, if you add 1, you get 3 over 3. So there's several ways you could do that. I was just kind of running out of space here. So this is my natural log series, and this was the general term I got from integrating that. Basically, the idea is if the natural log of x equals the integral of this, because the derivative of this equals that, so we can just take this and integrate both sides. So this is my series, and this is what you got. That was the general term again. So that was 63. So if that makes sense. And then 64, not too bad that we want to use